You should have grabbed a ruler and two colored pencils, two different colors, because we'll use that on the notes today. But your warm-up should be old news from the last couple times we did one together. Yesterday, you should have written sub. If you didn't, again, yesterday, write sub. Today, we're going to write these coefficients in a 3x3 matrix. So we have 2, 3, and what is in front of this z right here? A 1. Does everyone know that z is 1z, right? What about the next row? What's this first one? -1. Very good. And then the next one? It should be -1 again. Yes. Is it frozen? My bad. Thank you. Thank you very much. And then on the third one, that z is just a 1z, right? All right, third row, we have a 1x, 6y, and a 3z. So all I asked you to do on the warm-up is just to write what you would have typed. Okay, you don't have to type it in. But when we write it, in my big 3x3 matrix, I'm going to put 2, 3, and then 1. They can. -1, -1, and +1. Got 1, 6, and 3. And then what do we put next to the matrix at the top? Right. Little inverse -1. In the calculator, it's caret -1. Now, next to it, we're going to put a 3x1 matrix, which is the constants over here. So -3, 5, and -14. So this is all old news. Now, it came to my attention that yesterday, sorry, 2 days ago, / y'all were trying to finish yesterday, hopefully, the assignment for 2.3, people got stuck on number 3. Is that accurate?
Yeah.
Okay, so if you have your 2.3, I'm willing to help you out with number 3, and also let you know that if you do the front side, you can turn it in. That's good. Okay. So I think most people were able to do 1 and 2, got stuck on 3. Don't worry about 4, 5, 6, and then I'll help you with 3 right now. Sound like a plan? Okay, let me pull it up. So again, on assignment 2.3, okay, you can just do the front side. Okay, so what is it? 4, 5, and 6. 4, 5, and 6. You don't have to do them. You can. Okay, if you already did them, that's awesome. But on number 3, people were getting stuck. So let me help you because this actually does take a couple extra steps. It's kind of complicated. Now, it says in geometry, fun times, right? Okay. So in geometry, the sum of 3 angles is 180. Now, here's the deal. We need to define our variables. So what's x, what's y, what's z? Now, what are the names of these 3 angles in the word problem? A, B, and C. So let's just make it easy. X is A. Why is it doing that? X is A. Y is B. Z is C. Okay? So we set our variables. X is A. Y is B. Z is C. Now, if we're going to, that first sentence, it says the sum of 3 angles is equal to 180. What's a sum? What does that mean? What operation do you do when you do sum? Addition. Sum is when you add them up, okay? Like the sum total, add them up, okay? So if you know the sum of A, B, and C is 180, how can I write that as an equation? Well, what's the whole thing? A plus B plus C is equal to 180, and we're going to use X plus Y plus Z equals 180. I don't know why it's looking weird, but okay, so X plus Y plus Z equals 180, right? Now, the second sentence, if you're given a triangle in which you know B measures 5 degrees more than twice A, how could I write that as an equation? What do y'all think? Start with B. B is what letter? Y. It said measures, so it equals, and then how do I write 5 more than twice A? What should I write? What? Well, more than will be adding. Okay, so 5 more than will be a plus 5. And then twice A means 2 times x. So again, 5 more than twice angle A, twice angle A is 2x, and 5 more is adding 5. Okay, I know that's kind of weird. So let's think about it. B, which is y, is 5 more than, that's the plus 5, twice angle A, that's the 2x. So everything's there. Cool. Now, next one. Angle C measures 11 less than 3 times the measure of angle A. Okay, so start over. Angle C, what's the variable for C? Z. It says the measure, so I'll just put equals, 11 less than. How do I write 11 less than? It's going to have a minus 11 after it, okay? So what's it after? 3 times the measure of angle A, okay? So 3 times the measure of angle A is 3x. Okay. And then the 11 less than is minus 11. Cool. So that's how that works. I know it's weird. When you see 11 less than, you're putting the minus 11 after something. And then 3 times A is 3x. Okay. Cool. Now, you tell me, looking at these equations, what's kind of weird about them? Usually they're supposed to equal a number on the right side, and this one aren't in the right format. So we have to do some algebra. Okay, we got to move some stuff around. So with whatever room you might have at the bottom, do you have 2.3? I'm helping you do number 3 if you want to pull it out. So I'm going to rewrite this equation. Y equals 2x plus 5. And all I want to leave on that side is the 5. So how do I get rid of this 2x? Minus 2x on both sides. All right, so we have a negative 2x and the positive y. They don't combine because they're different variables. And then we have a missing z, right? So how would I write that all together? I have a negative 2x plus a y, and there's a 0z that's not even there, equals 5. So again, all I can have is a number, so I move this over by doing the opposite, and don't forget your missing term is a 0. We're going to do the same thing with this one. So z equals 3x minus 11. If I'm solving for the constant negative 11, how do I get rid of this positive 3x? Minus 3x. On both sides. So we have a minus 3x, we have a positive z, and we have no y. So remember, it's a 0y there, okay? So I'm going to write this out. Negative 3x plus 0y plus a regular z equals, and the number I bring down is not just 11, there's a negative sign with it. So it's negative 11. Okay, I know that's a lot. Okay, but now we have 3 equations with 3 variables equal to a constant. So what would now it's kind of like the warm-up. So what are my 3 variables on the first equation? Okay. So 1, 1, and 1. 1, 1, 1. What about the second equation down here? -2, 1, 0. Right? And then -3, 0, 1. Okay, I'll stop short of doing the matrix. I want y'all to do the matrix the way you did 1 and 2. Okay. Do y'all see the three equations here? So 1, 1, 1, -2, 1, 0, -3, 0, 1. And these are your three constants: 180, 5, -11. Okay. I'll give you 5 minutes to try to finish number 3 up, but then we got to do some notes, okay? So I know that one was tough. That's kind of how you started. So again, try to finish number 3. If you do finish number 3, just turn it in if you did 1 and 2. Because again, the backside, don't worry about it. Okay. Everybody, we're doing notes on 2.4. Now, we've done systems of equations, but today we're talking about inequalities, okay? Inequalities are not equal signs, but the less than or greater than signs, right? 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 All right. So it looks like this. Does everyone have a ruler and 2 colored pencils? 2 different colors, okay? There we go. So, listen. What is a system of inequalities? Okay, so again, system of inequalities. Set of 2 or more inequalities in 1 or more variables, okay? Systems of inequalities are used when a problem requires a range of solutions. It could be greater than or less than, and there is more than one constraint on those solutions. I'll show you what that means if you do this. So here's an example. Look right here, please. There's 2 forms of an equation. The left side, you don't have to write this down, but this is what it looks like. Standard form is like x, y, and then a constant on the other side. This is what we've been doing like on the warm-up where you have to put it in a matrix, right? So this works for matrices, but y'all are familiar with mx plus b from algebra 1, hopefully, okay? That's slope-intercept form. We need that today as we do this. Now, this information is kind of summed up on your notes on the left side in that little bubble, okay? But if you look right here, this, when it points, I say pointing, like think of it like an arrow. If it points to the left, left is a less than sign, okay? So again, pointing left, less than sign. Did you know it also kinda looks like an L, kinda. Okay? So if it points left and kind of looks like an L, then that's less than sign. Okay, kind of looks like a Pac-Man. Okay, so by the way, let me illustrate this at the top here. Okay, so if it looks like this, okay, that kind of looks like it could be a less than sign. Okay, kind of looks like an L, maybe. But if it looks like this, what letter does that look like? A G, if you're creative. Okay, hold on. Let me try that again. All right, ready? So look there, that G greater than. I would know because I am the G. All right, now less than, greater than. Now here's the other difference. The second and the fourth one have a little underline. Do y'all know what that little underline means? Don't do that. Okay, it includes the equal. Okay, so basically, if it's not underlined, it doesn't include it, and if it is underlined, it includes it. Now, oh, and I went too far ahead, but check it out right here. Less than will be a dashed line. So if it's not underlined, it's a dashed line. So do you see that in this graph right here? Less than sign, little dashes in your line, and if it's less, does everyone agree? Less means down below. So you would shade with one of your nice colored pencils below. Okay. So again, you don't have to do this right now, just looking up here. Now, if it's less than or equal to, do you see the subtle difference? The line is now solid. Underlined is solid. Not underlined is dashed. You've got to know the difference because when you graph these, if you do it wrong, it's wrong. Now, on the other ones over here, greater than, right? Or they put more than, but I say greater than, okay? If it's not underlined, it'll be a dashed line and you shade above, just like that one. Dashed, shade above. And then the last one, greater than or equal to, again, same line, but it's solid because it's underlined. Underline, solid line, shade above. Okay. Now, next slide here. This is what's on your notes. Okay, so on the left side, at the bottom of that little bubble thing. Okay? So if you get confused, you need to remember this stuff. This less than is dashed below. Less than or equal, solid line below. Greater than, dashed above. Greater than or equal, solid above. Does everyone see where that is on your notes so you can refer back to it if you get confused? Now, here's an example. It's not on your notes, so again, just look up here. Y equals x plus 4. Okay, now we're going to talk about how to graph these, but the x plus 4 is this line right here. Okay, actually, let me see if I can get my laser pointer. Laser pointer. Okay, so do y'all see right here? This is y equals x plus 4. And since it was underlined right here, do you see how it's a solid line? Okay, solid line because it's underlined. Cool. And then, since it's less than, that's why they shaded below it. So right here, they shaded everything pink or something like that, right? Then on number 2, it's a greater than sign. So the line is negative x going this way. And it's greater than, so they shaded above. And it's not underlined, so it's dashed. Okay. Now here's the question. Don't do that. What is the solution in this graph? What do you think? Okay, so negative 2, 2 is actually not a solution because it's a dashed line. Now, if they were both solid lines, that would be a solution. So here's the deal. The solution is actually an area, a shaded area. Which shaded area do you think it is? Over here? Okay, so the solution is where they both overlap. Okay? So again, if it's just in the pink down here, not good. If it's just in the blue up here, not good. Okay, so this is no good, this is no good, but it has to be over here in the double shaded area. The solution is all the ordered pairs, so any point in the overlapping shaded area. So today we're going to have 2 shades, that's why you got 2 colors, and wherever they overlap, anything in that is a solution. Okay? Yes, now this is the same picture. Now we're going to throw out some points here, okay? So 1, 1. That's in the double shaded area. That's a solution. Cool. Now, what about 0, 4? Now, on the edge is okay if the edge is solid. So 0, 4 actually is a solution because it's on a solid edge. Okay. Well, what about 2, negative 2? Same idea. If it's on a dashed line, that's a no-go. And then negative 2, positive 2 is also a no-go because one of them is dashed. So the only time it works is if you're on a one line that's solid or at an intersection of 2 solid lines, that works too. But basically dashes are out of bounds, okay? What about negative 3, 5? Well, that's in one shade, but not both, so that's not a solution. What about negative 3, negative 3? That's in one shade, but not both, so it's not a solution. Okay, do you see how that works? So the ones that are purple, 0, 4, 1, 1, anything in the double, that's a solution. Now, this, which of the following of these is in the solution? So 0, 0. Okay, right here, that's not in either. So no. What about negative 2, 0 right here? No. Even if it was solid, no, because it's not both. You know what I'm saying? 0, negative 1, what about that? Okay. So this is going to be a none of the above. Also, there is no double shaded area, right?
I was going to say, what if the red shading and the blue shading are both dash lines, but they're together? Would there still be line?
Yeah. On that line, no. Yeah. So these are not there's actually no solution here, so you would actually say no solution found, okay, in a situation like this. But let's go to the next one, okay? Now we're going to, now look at your notes. We're going to start writing some stuff. I want you to follow along with me on example 1, okay? Now, you see how we have two equations? Are these in slope-intercept with y by itself? No, these are the ones that are going to make us do some more work, so let's do them together, okay? I want you to take these two equations and put them side by side, just like this, okay? So go and write that down. Okay, so on the left, I put the top one on the left and the bottom one on the right. Both of these need to be solved for y, but we're going to start with the one on the left, right? So on the left, what do I need to get rid of first?
The -2.
Yeah, right here, there's minus 2x. What's the opposite of a minus 2x? Plus 2x. So your first step, now the way they did it on the notes, they kind of just drew an arrow. But you know you're adding 2x to both sides, right? You cancel it out on the left, and then you, on the right side, you put it in front of the -3. So it looks like this. Okay? Plus 2x goes to the right, you put it in front of the constant -3. And now, y is by itself. Okay? Now here's the question. What is m and what is b? So what's my slope? Just looking at that equation, or actually, sorry, what's my y-intercept? If it's mx plus b, which one's the y-intercept? The b. The -3 is going to be my y-intercept. Now careful here. What's the slope? Okay, so we're going to use the 2, but we'd like to have it as a fraction, a rise over run. So what is 2 written as a fraction? 2 over 1. Okay, so slope is 2 over 1.
Oh, I see what you did with the line. You moved it over, like it overlapped on the other side. Okay, I didn't get that.
Wait, what?
Like you switched the.
This?
Yeah.
Put it over and put it right in front of the -3.
Yeah.
But
I didn't get that at first.
Yeah, but it's opposite. So like, really, oh my gosh, what just happened here? Really, what I would have done is plus 2x plus 2x, and this goes in front. Yeah. Okay, now we want to graph this thing. So let's see here. So everybody, when you graph mx plus b, do you graph the m or the b first? What do y'all think? B. So B for beginning. You begin at the B. Okay, so let's start at that -3 on the y-axis. Go ahead and put a -3 right there. Okay, so now it's up to you. You can use your color now, or you can wait to shade with the color. It doesn't matter. Okay, but go and put a point at -3, and then use your slope to rise over run to get the next point. Okay, so starting at -3. Right here. Now I'm going to rise 2, run 1. So up 2, over 1. And then you can do the same thing. Rise 2 over 1, up 2 over 1. And just put a bunch of points there. Boop, boop, boop. Now, we want to use our ruler to make nice straight lines. But before we make a line, what kind of line is it going to be? So look right here. This is a underline. So is it solid or dashed? Underline is solid. So when you draw that line, make it a straight line, no dash. Okay? It's going to look like this. Bam! Now, can we solve the next equation and do the same thing? Actually, no, we're not done. My bad. The other thing about it, it's a less than sign. Which way do I shade that? Above or below? Less than or equal to is shaded below. So now, for sure, with your color, shade below that solid line. It'll look something like this. 5 over 1, 2 up 2 over 1, 2 over 1, up 2 over 1. And so it's underlined, you put a solid line. And then you shade below because it's less than. Alright, so y'all know usually I'm not cute. We don't do colors and stuff, but today, you know, it'd be nice to see different colors, you know? So last period said we should do it. So I was like, let's be cute. Ooh. Ooh. All right, so second equation. I want to solve for y. So 2x plus 3y, what do I need to get rid of first? The 2x. How do I get rid of a positive 2x? So you're going to subtract 2x from both sides, really. So let me draw that. It's not on the notes here. So I would put minus 2x, and that goes right in front. So that minus 2x goes in front of the positive 3. So it's going to look like this. Now, how do I get rid of the 3 in front of y? Divide. So divide by 3. Everything gets divided by 3. Whoops. So the 3y gets divided by 3. The negative 2x gets divided by 3. And the 3 gets divided by 3. Well, okay, so the far left, the 3's cancel out. Yeah, so you have y less than. The negative 2 over 3 is going to stay negative 2 over 3. And then the 3 over 3 gives you 1 for your constant, your b value. Now, if you got all that, so what's my y-intercept? Mx plus b. What's my b? 1. What's my slope? Negative 2 over 3, right? B is the constant. Negative 2 over 3 is the coefficient in front of x. Can you graph that line? Well, mx plus b. What do we graph first, m or b? B for beginning. Where do we begin? 1. So put a point at 1. It'll look like this. Bam! It's a red point for me. And then your slope is negative 2 over 3. Now, which way are you rising and running? Down 2, and you always run to the right, like a Mario. Okay, down 2, right 3. So 1, 2, 1, 2, 3. Put a point right there. And then you can do it again, and then you can actually go backwards even. Get those nice points for that line. But then, here's the question. What kind of line is it? What kind of line is it? Of course.
You repeated it, so I thought I was
No. Just trying to. So, what is it? Dashed or solid, and is it shaded above or below? So let's look at the inequality. It's a less than sign. So is that? It's not underlined. So do I dashed or solid? What do you think? It's not underlined. Dashed line. Again, and if you look over here at this little thing right here, y'all see this right here? It kind of tells you off to the side. Okay, so it's a dashed line. So when you draw it, make sure you leave some little spaces in between your little marks. And which way am I going to shade that thing? Above or below? What? Why below? Less than sign. Below. So here's my shade. I'm throwing shade. All right. So your second color, okay, again, you might want to do different colors. Now, technically, you could just do both the same, and it would just be a little bit darker where they overlap, whatever. But if you want to be cute, that's how cute it is. You got it overlapping colors. You might even create a new color. You may take a yellow and a blue and make a green. Okay. Now, man, I'm about to get to the good stuff here. It's just about to get real good. Yeah, we don't have enough time for you to go. Sorry. Now, where is the solution? The double shade, right? So right where my little laser pointer is. Anywhere down here, right? And on this solid line. Cool?
Cool. So we can just mark anything in there.
Well, so if it was multiple choice and it said, is this point a solution, as long as it's in the shaded or solid line, okay? Now, real quick, example 2, and I'm talking about real quick. I'm gonna do this with y'all. Y'all ready? Don't blink. Ready? 2x plus y equals, sorry, less than 8.
We don't have to write this down.
Sure you do. Now, what do I get rid of first? Flip it over on the back, number 2. I get rid of that x, so minus 2x, put that in front. So y is less than minus 2x plus 8. If I have a minus 2x, how do I write that as a fraction? I put it over what? No, a whole number goes over 1, over 1. Whole numbers are over 1. Remember that, so you don't have to say goofy things. I need you to talk. All right, and my second equation, x plus 3y less greater than or equal to 12. You subtract x. Yeah, bell to bell. Negative x plus 12. Divide by 3, bless you. That's really a negative 1. So you get y is greater than or equal to negative 1 over 3x, and then 12 over 3 is 4. Let's graph these things. The first one in red, positive 8 is going to be off the grid, and I'm going to go down 2 over 1, down 2 over 1. Now, since it's not underlined, this is going to be a dashed line, dash, 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 dash. Less than is shaded below, right? Yes, Mr. G. Yes, and then the other one, at positive 4 is my y-intercept, negative 1 over 3, down 1 over to the right 3. This is underlined, so it's a solid line, and you shade above because it's greater than. And then you can see the double overlap is right here. And then example 3 you can do on your own. Fun.